So we're going to look at the intermediate value theorem. And this theorem has a lot of applications all throughout the course. It's a pretty simple theorem, but its applications are great, I should say. Okay, it's called the intermediate value theorem, and we use it a lot, and a lot of times we just call it IVT. So sometimes we're justifying something, and we'll say, oh, we're justifying that by the intermediate value theorem. We don't have to redo the whole theorem, nothing like that, and we're able to just put IVT. Okay, in a nutshell, it says if you have some function, okay, any function at all, and that function is continuous on some interval, okay, so on some interval, it's continuous. Well, that means that it has to go through every y value to get from A to B, that no y value can be skipped as long as it's continuous. Okay, sounds pretty basic, right? Okay, so let's put this down here. So it's saying if a function is continuous on a closed interval, remember closed interval, that's where we get the brackets. That means that it's left-hand continuous at A, right-hand continuous at B, excuse me. Then f of x, or the y value, takes on every value between f of A and f of B on that interval. Okay, so I know you'll need to pause the video to write that down. But basically, what it's saying here is, okay, here's A, here's the y value that goes with A. Here's B, here's the y value that goes with B. It's going to take on every value in here. So let's kind of put like that no y value is skipped. Okay, now given that f of x is continuous on AB. If you did not know that it was continuous, who knows? It could have an asymptote in there, it could have a hole in there, it could have anything going on. But if you know for sure it's continuous, then you know for sure every y value between f of A and f of B, there are infinite points and infinite y values that go in through there. Okay, let's look at another example here. And let's just say we have like the number 4 here, number 20 up here, and maybe I have the number 3 right here, and the number 8. Okay, so I've got a continuous function on a closed interval. Remember, the interval is 3, 8, not 4, 20. Okay, that's the interval. Okay, here's the way that they ask this question that's kind of weird. It'll say, is there a value x equals c? So c is just saying some value. Is there some value on the interval 3, 8 such that f of c equals 10? So it's a weird way of asking a question. So basically what they're saying is, okay, look, this is continuous. All the y values, it has to go through every value from 4 to 20. So they're just saying, is there a point that the y value would have to be 10? Yes, because it has to go through every point from 4 to 20. Okay, so now, how would you justify that? So you're going to say yes. And you're going to start by f of x is continuous. So you got to make sure that you're always justifying that continuity right there. And in this case, we know just because we're given the graph. Okay, on 3, 8. Okay, therefore, we know that 4 is less than or equal to f of x, which is less than or equal to 20. So we know that every y value has to occur between 4 and 20. So I'm going to put, since f of c equals 10 is in the interval, there must be, okay, so I should say in the interval, in this interval right here, a c value such that got to be somewhere between 3 and 8. Okay, so you know that somewhere in here is a 10. Let's say that that 10 is right here. And I go over there, and I go down, and there's its c value. Okay, so a weird way of asking a question. And it's not always going to be this weird, you guys. Okay, just keep that in mind. Okay, let's look at one other equation here. Oops. Or I guess I should say picture. So let's say that we have a 2 right here. Oops, would help if I did that. And maybe a 1 right here. And let's say we're going to have a hole in this one. And so it goes like that. And let's say that this up here is 12. And this right here is 5. Okay, so in this case, we don't have a guarantee that every value from 2 to 12, and every y value from 2 to 12 is going to show up because there's a hole in this graph. Okay, so the way you might see this question is it might say, does the intermediate value theorem, the IVT, guarantee a value of C on the closed interval 1 to 5 such that G of C equals 6. Or let's not even make it 6. Let's make it like 4. Let's do that. So they want to know, is that guaranteed in here? That they're giving you a number in here, so it has to go everywhere. All the y values have to go between 2 and 12. But we don't know where that's at. So maybe that's at 4. So I can't guarantee it. Okay, so this is what I'm going to write. I'm going to write no, since f of x is not continuous on the closed interval 1 through 5, or 1 to 5, there is no guarantee that all function values between 2 and 12 exist. And then I'm going to say the intermediate value theorem cannot guarantee there is a C value such that f of C equals 6. Okay, so we'll stop there on that page. Like I said, it's not going to be this weird the whole time.